You know, in every single home, every office, basically every building we use, there's this hidden safety system. It's working 24/7 to protect us from a really silent danger. It's this huge network we all rely on, but most of us never even see it. So today, we're going to pull back the curtain on this invisible shield and really explore the world of electrical earthing.
I mean, you've seen it 1,000 times, right? That third kind of round pin on a plug. It's not just there to make it fit better. No way. It's the key. It's the single point of entry into this entire protective system. And trust me, by the end of this, you'll know exactly how that little pin keeps you safe.
All right, so why do we even need this system in the first place? Well, the answer starts with a really simple but, well, potentially deadly problem that can happen inside any of your appliances.
Just picture your toaster or your microwave, even your washing machine. Inside, you've got live electrical wires. Now, if just one of those wires gets frayed or comes loose and touches the metal casing, that whole outer body of the appliance instantly becomes live. It's just waiting for someone to touch it.
So there's actually an official term for this kind of hazard, an exposed conductive part. It's just the technical way of saying any metal part you can touch that shouldn't be live, but could become live if something inside goes wrong. And that's the danger zone.
So how do we solve this pretty shocking problem? Well, we go right back to that third pin. Turns out, it's not just a pin, it's a promise of safety. See, that pin is your appliance's connection to the earth wire that's in your wall. And that wire connects to a massive network of conductors running through your entire building and ultimately connecting it physically to the ground right outside. So how does this connection actually help? Well, it all comes down to a really simple principle. If electricity is flowing where it shouldn't be, you have to give it a safe place to go. You've got to give it an emergency exit. And this is the whole idea behind earthing, or grounding as it's sometimes called. It's all about creating a super easy path, a path with almost no resistance, for that stray electricity to follow. See, electricity is kind of lazy. It always takes the easiest route. And the earth wire provides a path that is way, way easier than going through your body. So here's how it all comes together in a split second. Let's walk through it. First, a wire touches the metal case. Then, instead of just waiting for you to touch it, the current immediately rushes down the earth wire, its new emergency exit. Because this path is so easy, a huge amount of current flows, a massive surge. And that surge is so big that it instantly trips your circuit breaker or blows the fuse, shutting off the power completely. The danger is gone before you even knew it was there. I mean, the difference here couldn't be more clear. Without earthing, you've got a silent trap just waiting. With earthing, the system protects itself, and you automatically. It's the difference between a life-threatening situation and, the minor inconvenience of having to go flip a breaker.
Okay, so this all sounds great in theory, but how is this system actually built? For that, we're going to look directly at the blueprint engineers use, the Indian Standard 3043, which lays out exactly how to create this invisible shield.
First things first, identification is absolutely critical, and the standard is incredibly strict about this. The protective earth wire has to be colored with a green and yellow combination, and, get this, that color code can never be used for any other wire. It's a universal signal for safety. Okay, but how do you physically connect a building to the entire planet? This is where the actual hardware comes in. The standard lays out a few ways to do it, but two of the most common are the pipe electrode and the plate electrode. They're basically just large pieces of metal that get buried deep in the ground to make that final, crucial connection. But it's not just about digging a hole and burying a piece of metal. If you look closely at this diagram, you see it surrounded by these alternating layers of charcoal and salt. Now, this might seem kind of low-tech, but it is brilliant engineering. The salt and charcoal help hold on to moisture, and they actually increase the conductivity of the soil around it, creating an even better connection to the earth. And this brings up a really crucial point. Not all ground is created equal. The standard has data on something called soil resistivity. Just look at this. Wet clay is a fantastic conductor. It has low resistance. But dry, stony ground or solid granite, it's terrible. So engineers have to know the local geology to design an earthing system that's actually going to work. Sometimes they have to drive those electrodes way deeper just to find soil that's good enough.
So we've gone from a single plug all the way down to an electrode in the ground. Now let's zoom out and see how this whole concept scales up to perfect an entire building.
The next level of protection has a fancy name, equal potential bonding, but the idea is pretty simple. It's about connecting all the other metal things in a building, like water pipes, gas lines, the steel frame itself, and hooking them all up to the main earthing system. This makes sure that if there's a fault, everything is at the same electrical level, which gets rid of dangerous voltage differences between things you might touch at the same time.
And this is where you see just how deep this system goes. In big buildings, engineers will literally weld connections from the earthing grid directly onto the steel rebar inside the concrete foundations. What that means is the entire skeleton of the building becomes a part of this protective shield. It's incredible. So, as we start to wrap this up, it's really worth thinking for a second about the document that makes all of this possible.
You know, this standard isn't just some dry, technical manual. It represents decades of experience, of physics, of hard-won engineering wisdom, all collected and written down to make sure that the invisible shield around us is built correctly every single time. It's literally a blueprint for saving lives.
And just to really hammer home how important this all is, the standard itself includes this powerful quote from an Indian social movement. It says, "The right to information, the right to live." It's this profound reminder that having access to this kind of technical knowledge isn't just an academic thing. It's fundamental to our safety, to our right to a safe life.
So the next time you plug something into the wall, maybe take a look at that third pin and think about the massive invisible system it connects to. This network is keeping us safe every single day. And it kind of makes you wonder, right? What other hidden engineering marvels are out there, quietly making our modern world possible?